It's funny, isn't it? We humans like to think we've got a handle on things. We invent words like universe, galaxy, and light year, and then casually drop them into dinner conversations as if our brains were built to comprehend infinity. But the truth is, most of us can barely comprehend the distance from our couch to the fridge when we're too tired to get up. So imagine trying to wrap your head around space. Not just the night sky looks big kind of space, but the actual, mathematically absurd, melt your cortex size of the cosmos. We cling to our little neighborhood, the solar system, because it's familiar. The sun is our campfire. Jupiter is that big older cousin who hogs all the snacks. Mars is the moody teenager who wants to move out. And Earth, well, that's us, still trying to figure out how to pay the rent and recycle properly. These planets are familiar faces at a cosmic family reunion. Safe, predictable. They keep us grounded. But beyond that, beyond the heliopause, the invisible bubble carved out by the sun's solar wind, a bubble that stretches more than 18 billion kilometers away, there is a darkness that does not care about us. A realm so cold and empty that calling it lonely feels like an understatement. It's interstellar space, the great, black, indifferent ocean that lies between the stars. And only two human-made objects have ever dared to leave the safety of the bubble. Not spaceships with plucky astronauts, not probes designed for glory, but the quiet, stoic Voyagers. Voyager 1 and Voyager 2. They slipped past the planets decades ago, still whispering faint signals back to us, like old postcards from an uncle who decided to walk into the desert and just kept going. They're the only machines we've ever sent into true interstellar space, our only ambassadors to the void. Think about that. Two fragile lumps of metal representing all of humanity, carrying our mixtapes of whale songs and Chuck Berry. Now here's the twist. While we've sent things out, every once in a while the cosmos sends something back in. Visitors, outsiders, strange interstellar hitchhikers that wander across the galactic highway and accidentally pull into our driveway. The first one arrived in 2017. You remember the buzz. A long, cigar-shaped rock with a Hawaiian name. Oumuamua, Scout. It whipped past the sun like it had somewhere better to be. People argued. Was it an asteroid? A comet? A shard of a shattered planet? Or whisper it an alien probe? Spoiler, we still don't know, which is both terrifying and delightful. Then came Borisov in 2019. A real comet this time, spewing gas and dust, like an excited tourist spraying champagne at New Year's. Astronomers scrambled, telescopes swiveled, and suddenly we realized, oh, these things don't just exist in science fiction, they actually drop by unannounced. And now, after a few years of cosmic silence, the universe has done it again. Another stranger has wandered in. Its name is 3IATLAS, the third interstellar object we've ever seen. A name so unglamorous, it sounds like a forgotten printer model, but behind it lies a story both strange and exhilarating. It has traveled untold billions of years, crossed distances we can't measure with anything but metaphors, and somehow, improbably, arrived here, in our backyard. So tonight, my sleepless friends, we begin the story of this visitor. The where, the how, the why on earth should we care of 3IATLAS. By the time we're finished, you'll see how something as small as a 10-kilometer chunk of ice and dust can make us rethink not just the solar system, but our place in the galaxy itself. Because when the universe sends you a guest, uninvited and mysterious, you don't slam the door. You watch, you study. And maybe, if you're like me, you whisper a little thank you into the night sky for reminding us that we are still wonderfully small. The date was the 1st of July. For most of us, it was just another Tuesday or maybe a Monday, who knows anymore, calendars are suggestions. But for astronomers in Chile, something unusual flickered into their telescopes. The ATLAS project, short for Asteroid Terrestrial Impact Last Alert System, was doing its nightly rounds, quietly scanning the heavens. You see, Atlas is kind of like that one friend who's always looking out for you, the one who'll text at 2 a.m. to say, "Hey, don't forget your ex is back in town." Except instead of X's, Atlas watches for asteroids that might, end civilization. Small difference. The project runs on 4 telescopes scattered across the globe: Hawaii, South Africa, Chile, like a cosmic neighborhood watch. Each telescope takes about 800 images every night, clicking away as faithfully as your grandma's knitting needles. Over the years, Atlas has spotted over 1,000 near-Earth objects, the kind of rocks that fly a little too close for comfort. Most of these are boring asteroids no one names, pebbles compared to planets. But that night in Chile, Atlas's camera blinked at something that was anything but boring. From the direction of Sagittarius, the so-called Teapot constellation. Yes, that's really what we call it. Astronomy can be whimsical when it wants to be. The telescope caught an object moving fast, cutting across the images like a streak. Nothing new there. Atlas lives for that kind of thing. But this streak, it didn't behave like the usual suspects. It wasn't just some rock looping lazily around the sun like a drunk uncle at a barbecue. Number. This thing was on a straight beeline, barreling in from the depths. At first, it was slapped with the temporary name A11PL3Z, which sounds less like a space rock and more like a Wi-Fi password you'd forget instantly. But boring name aside, this rock had personality. Its path screamed, "I don't belong here." Within hours, the alert made its way to the Minor Planet Center in Massachusetts, the cosmic traffic cops who keep track of everything drifting through our solar neighborhood. And the chatter began. Was this just another asteroid? Or was this something rarer, stranger, another foreign guest? The telescopes didn't know yet, but they'd stumbled on something that would soon pull the attention of every astronomer from Cambridge to Canterbury. Because sometimes the universe doesn't knock politely. Sometimes it barges in, wearing a name tag no one can read, and everyone has to figure out what it wants before it disappears again. Here's the thing about astronomy. Nothing ever happens in isolation. When Atlas spotted that streak on the 1st of July, it wasn't the first time this object had been seen. Not even close. Astronomers, like detectives who never delete old emails, keep a mountain of pre-discovery data, snapshots of the sky, taken before anyone knew what they were looking at. And when the Minor Planet Center, the cosmic DMV of rocks and ice, dug through those records, they found that this so-called newcomer had actually been photobombing us for weeks. Back in mid-June, the Zwicky Transient Facility in California had already captured it, tucked in among stars like a gatecrasher. No one noticed. Other Atlas telescopes had too. Only later, once the orbit was pieced together, did the penny drop. Oh, that streak? Yeah, that was it. Imagine realizing you'd had an alien wanderer sitting in your vacation photos the whole time, smiling in the background while you were too busy posing with the Eiffel Tower to notice. And what an orbit it turned out to be. Not circular, not elliptical, not even slightly eccentric, in the way your uncle, with the conspiracy theories, is eccentric. This thing was hyperbolic, so hyperbolic it practically shouted, "I don't live here." Its eccentricity wasn't just above the line for, "Okay, you're not bound to the sun anymore." It was way beyond that, like buying a one-way ticket into the galaxy and never planning to come back. That was the smoking gun. This object had come from interstellar space. Not some forgotten corner of the Oort cloud, not a detour from Neptune's debris field, But the real deal, born around another star, flung into the void, and after who knows how many millions or billions of years, arriving here. And so, the bureaucrats at the MPC got to do their favorite thing, name it. The official designation? 3I, ATLAS. The 3I stands for Third Interstellar Object. The Atlas is for the telescope that nabbed it. Not exactly poetic. No Polynesian mystique like Oumuamua. No down-to-earth surname like Borisov. Just 3I. Atlas like the third installment of a movie franchise nobody asked for, but suddenly everyone's excited about. But if the name feels dry, the implications don't. With only 2 previous interstellar visitors ever recorded, the arrival of a third isn't just news. It's history. Every scrap of data, every pixel of light, becomes a piece of evidence in a story billions of years old. And astronomers, those patient detectives of the sky, were suddenly holding an entirely new case file in their hands. At first, astronomers weren't sure what they were looking at. Was 3IATLAS just another interstellar rock, a glorified pebble flung across the galaxy like cosmic litter? Or was it something more alive, more dynamic? See, when a lump of ice and dust gets close enough to the sun, it starts to wake up. The ice vaporizes, the gas escapes, and suddenly that lump sprouts a fuzzy halo. That halo has a name: coma. Now, comas are the calling cards of comets. They're messy, they glow, they announce to the universe, "Hey, look at me, I'm fabulous." Asteroids, on the other hand, tend to be boring, solid, rocky, not much showmanship, and for a while, no one knew which camp this visitor belonged to. But as the data rolled in, the verdict became clear. 3I. Atlas wasn't just a rock. It had a coma. A faint one, sure, but enough to prove it wasn't just drifting aimlessly. It was actively reacting to the sun's warmth. That single fuzzy blur changed everything. The object was reclassified, given yet another name: C 2025 N1, the C meaning comet. And just like that, this alien wanderer joined a club that includes every icy misfit we've ever admired through backyard telescopes or children's science books. But this wasn't just about slapping a new label on it. It was about possibility. Comets carry stories in their dust. They are time capsules, little frozen archives of the conditions under which they formed. Imagine opening a vault sealed not for centuries, not for millennia, but for billions of years, a vault built in another solar system entirely. That's what this coma represented. A chance to peek at ingredients from a different cosmic kitchen. And the excitement? Palpable. Astronomers began calling for more observations, more telescopes pointed skyward, more funding to squeeze every ounce of knowledge from this fleeting guest before it slipped back into the abyss. Because that's the cruel thing about interstellar visitors. They don't linger. They swing in, make a cameo appearance, and then vanish, probably forever. But this brief encounter was already enough to rewrite a textbook or two. We hadn't just spotted another nameless rock. We'd welcomed the comet from the stars, a glowing traveler with a story older than Earth itself, now caught in our spotlight, even if just for a moment. Now, before your imagination starts painting doomsday murals, let's clear something up. 3I. Atlas is not coming to kill us. It's not on a collision course. It's not hiding secret alien spores. And Bruce Willis doesn't need to suit up for a last-minute drilling mission. At its closest, this comet will still be about 1.6 astronomical units away from Earth. That's over 600 times the distance to the Moon. In cosmic terms, that's like saying, yes, the stranger came into town, but they rented a motel on the outskirts and won't be knocking on your door. Safe, distant, comfortably unthreatening. But safety doesn't mean boring. Quite the opposite. Because this safe distance gives us something precious: time to watch, to study, to point every telescope we can at it without also worrying about evacuation plans. And that's rare. Think about it. We're getting front row seats to a visitor that has likely spent billions of years wandering interstellar space, and we get to observe it calmly, like birdwatchers spotting a rare species from a safe perch. And really, if we're honest, the danger isn't the comet itself. The danger is missing the moment. These things don't happen often. We've only had 2 interstellar guests before this. Oumuamua in 2017, Borisov in 2019, and now 3IATLAS. That's it. 3 in the entire history of astronomy. This is not a revolving door. It's more like lightning striking the same tree 3 times in different centuries. So, no, it won't wipe us out. It won't even rustle our atmosphere. But it will, for a brief window of time, remind us that the universe is not a closed system. That beyond our sun's protective bubble, there's a whole galaxy of wanderers, strangers who sometimes, by sheer cosmic accident, wander into our corner of the neighborhood. And if you can't get excited about that, I don't know what to tell you. Maybe get a telescope, or at least a good cup of coffee. Here's where things get spicy, because it's not just the fact that 3IATLAS showed up that makes it special. It's how it showed up. The orbit isn't normal. In fact, it's so abnormal that calling it eccentric feels like an understatement. Now, quick refresher. Orbital eccentricity is just astronomer speak for how much your path looks like a circle versus how much it looks like a drunken escape route. An eccentricity of 0 means you've got a perfect circle, neat and tidy, like Saturn showing off its rings. A value between 0 and 1, that's an ellipse, like Earth's orbit. Not perfectly circular, but close enough that we don't notice unless you're really into math. A value of 1 is parabolic, the exact escape hatch, the cosmic equivalent of putting in your 2 weeks' notice. But 3IATLAS? Its eccentricity is about 6. 6. That's like handing in your 2 weeks' notice, then stealing the office printer, crashing through the window, and speeding off in a stolen car. It's not just leaving, it's leaving dramatically. This is why astronomers immediately knew it wasn't local. No object born in our solar system ends up with an orbit like that, unless it's been slingshotted around by something extreme. Hyperbolic trajectories are the signature of interstellar travelers. They come in fast, swoop around the sun, and then poof back out into the galactic dark, like cosmic one-night stands. And there's something almost poetic about it. Most comets we know are bound to the Sunday. They orbit endlessly, some on short loops like Halley's Comet, others on thousand-year pilgrimages from the Oort cloud. They're like pets, loyal to their master star. But interstellar comets? They bow to no one. They're the drifters, the hitchhikers, the wanderers who stopped obeying a star's pull long ago. So when we look at 3IATLAS, we're not just seeing a comet, we're seeing freedom in motion. A body cut loose, crossing light years with no leash, no return ticket, and only the faintest chance that we, by cosmic coincidence, happened to glimpse it as it passed. If the orbit wasn't enough to raise eyebrows, the speed certainly was, because 3IATLAS isn't just drifting into town at a casual jog. No, this thing is tearing through space like it stole something. Right now, its incoming velocity clocks in at about 58 kilometers per second. That number probably doesn't mean much on its own, so let's humanize it. Imagine running across 580 football fields in a single second, or crossing from New York to Los Angeles in less time than it takes to blink. At that pace, you wouldn't just miss your train, you'd lap it 6 times before the doors closed. For context, our previous interstellar celebrities were practically sluggish by comparison. Oumuamua clocked in at around 26 km per second. Borisov hit 32 km per second. Fast, yes, but in the way a sports car is fast. 3IATLAS, on the other hand, is a hypersonic missile with zero patience for traffic laws. And here's the kicker. This speed isn't just for show. It's part of why we know it came from interstellar space. Only an object born under a different star's gravitational embrace, then flung loose into the galaxy, could carry that kind of momentum. It's been gathering speed for eons, like a cosmic snowball rolling downhill across light years, and now we're the bystanders catching a glimpse as it streaks by. But speed comes with a price. It means we won't have long. By the time we've scheduled telescopes, calibrated instruments, and argued on Twitter about what it really is, 3IATLAS will already be halfway out the door. Astronomers are scrambling, not just because it's rare, but because it's fast. Blink, and this chapter of cosmic history is gone. Still, for these fleeting months, we have a front-row seat to the fastest interstellar visitor ever recorded. Which raises a very human question. If the universe occasionally drops off guests like this, what else is speeding past while we're too busy watching Netflix to notice? So we know 3IATLAS is fast. We know it doesn't belong here. But the natural next question is, where exactly is it going? Because in astronomy, half the job is just drawing lines on a graph and hoping the rock behaves. Here's what astronomers figured out. Right now, its path is heliocentric, meaning it's temporarily caught in the sun's gravitational field. Picture it like a drifter stopping at your campfire for warmth before heading back into the night. It's not bound to stay, but for a brief moment, it's playing by the sun's rules. Its closest approach, the big moment, is scheduled for the 30th of October, when it'll swoop to about 1.4 astronomical units from the Sunday. That's just inside the orbit of Mars. Think of it as brushing past the red planet's shoulder before veering off into the galactic dark. If you were to plot its trajectory, it wouldn't look like a neat loop, not even close. It's an asymptotic curve, a long swoop inward, a tight bend around the sun, and then a slingshot outward, back into forever. Like a stone skimming a pond, touching the surface just once before disappearing into the air again. And when you line up the graphs, you see something curious. Oumuamua, back in 2017, dove much closer to the sun, practically grazing it like a daredevil. Borisov, on the other hand, took a path more distant, a little less reckless. 3IATLAS? It's somewhere in between. Not as bold as Oumuamua, not as cautious as Borisov, just a solid middle ground commuter passing through. But don't let that middle ground fool you. The orbit is extreme, the kind of geometry that screams interstellar origin. It's a reminder that while we tend to think of our solar system as the main stage, in reality, it's just one stop on a much larger galactic tour. For 3IATLAS, the sun is just a roadside diner, and we're the curious locals peeking through the blinds, trying to guess the story of the stranger who ordered coffee and left without a word. When word spread that we had a third interstellar visitor, astronomers did what astronomers do best. They panicked in a very organized way. Telescopes all over the planet began to swivel. Observation schedules were torn up, replaced with frantic notes. Point here, watch this, don't miss it. Because time, remember, is short. At the speed 3IATLAS is moving, every hour counts. So, the big guns came out globally, distributed telescopes like those at the Las Cumbres Observatory, LCO. These observatories specialize in catching transient events, astronomy's way of saying, blink and you miss it. Supernovae, gamma-ray bursts, outbursts from comets, and now, an alien wanderer crashing our party. In particular, two modest LCO telescopes in Hawaii, each just 0.36 meters in diameter. Basically, the binoculars of the professional astronomy world were scheduled for a 1-hour marathon observation. Their job? To track brightness. To measure how the light from 3I/ATLAS changes over time. Because changes in brightness can tell us if the comet is spinning, tumbling, or otherwise showing off. This isn't just curiosity, it's detective work. Imagine trying to understand a stranger by the way their shadow flickers under a street lamp. Maybe the shadow grows brighter when they face you, dimmer when they turn away. Maybe you notice a rhythm, a step, a pause, a spin. That's what astronomers are doing, but with photons crossing hundreds of millions of kilometers. And here's the wonderful thing. It's not just the professionals. Amateur astronomers, armed with backyard telescopes and sheer enthusiasm, have joined the hunt. In forums like the Astronomers Telegram, new posts are dropping daily. Updates, measurements, even photos. Some grainy, some gorgeous, all piecing together a collective portrait of this visitor. For a fleeting moment, humanity is united in a very strange way, staring at a 10-kilometer-wide lump of ice and dust that doesn't even know we exist, and yet we're all invested in its story. Because deep down, we recognize the romance of it. The thrill of knowing that across countless light years, a traveler has wandered into our sky, and we get to bear witness. So, what did those telescopes find when they locked their gaze on 3I/ATLAS for an hour straight? They were searching for a heartbeat, a rhythm, some clue in the way the comet brightens and dims that would betray its rotation. And they found one. The data suggests that 3I/ATLAS spins once every 29 hours. That's just a little longer than an Earth day, so if you lived on this comet, your calendar would be a mess. One day would drag across nearly a day and a quarter back home. Not that home on a 10-kilometer ice rock is anyone's dream vacation spot, but still, the numbers matter. What surprised astronomers, though, was how flat the light curve looked. The comet's brightness barely changed, just about 0.2 magnitudes, up or down across the entire rotation. That's subtle. Oumuamua, for instance, had wild swings in brightness, as if it were a badly shaped baton spinning chaotically in the void. Some even thought it was a thin pancake, or maybe a shard of something larger. But 3I/ATLAS? Steady, calm, almost boring in comparison. And yet, boring can be beautiful. Because while the brightness variation was minimal, the overall glow was impressive. This comet is bright. In fact, it's the brightest interstellar object ever spotted. Right up until late May, it was faint, lurking around a magnitude of 20 astronomy's version of a whisper. Then, almost overnight, it flared, climbing to a much more noticeable 17.7 to 17.8 magnitude in the O band. Still faint to the naked eye, but through the right instruments, a genuine beacon. To put this into perspective, 3I/ATLAS is far larger than its predecessors. Its nucleus, based on how much sunlight it reflects, is estimated to be about 10 kilometers across. That's an order of magnitude bigger than Oumuamua, which was less than half a kilometer at best. Bigger even than Borisov, which was around 2. This isn't a pebble. It's a mountain adrift in space. So here we have it. A comet that rotates lazily, doesn't flicker much, but shines bright and carries serious bulk. If Oumuamua was a mysterious stick and Borisov was a fussy firework, then 3I/ATLAS is the heavyweight contender, slower, steadier, but commanding attention simply by showing up. When it first crept into our telescopes, 3I/ATLAS was shy, almost invisible. A dim speck buried in the crowd of background stars, whispering at magnitude 20, so faint that only trained eyes and sensitive instruments could pick it out. The kind of object you'd overlook unless you were deliberately hunting for cosmic wallflowers. But then, sometime in late May, the shy guest decided to step into the spotlight. Over just a few weeks, its brightness surged, climbing to around magnitude 17.7. That may not sound like much, it's still far from naked-eye visibility, but in astronomical terms, that's like a whisper turning into a steady hum you can hear across the room. Bright enough for the right amateur telescopes to join the party. And the reason? Size. At an estimated 10 kilometers wide, this is no pebble tossed into our skies. This is a mountain. For comparison, Borisov, our interstellar visitor in 2019, measured between 1 and 2 kilometers. Oumuamua, back in 2017, was smaller still, maybe half a kilometer at most. Next to them, 3IATLAS is Goliath. If you parked it over Manhattan, the edges would spill out into the Hudson and East Rivers with room to spare. It's also carrying a touch of activity, enough to make itself stand out. A faint coma of gas and dust has been recorded. Not the wild fireworks display of Borisov, but something subtler, a soft halo, the kind you almost miss if you're not looking closely. It's like the comet is exhaling gently as it warms under the sunday, and in that coma, astronomers see potential. Each molecule of gas, each grain of dust, is a clue. It's the comet's autobiography, written in chemistry instead of ink. If we can read it, we can learn not just about 3I, Atlas itself, but about the star system where it was born. What elements were abundant there? What ices survived? Was it a hot nursery or a cold, distant region like our Kuiper belt? That's the real excitement. Because brightness isn't just about spectacle, it's about accessibility. A bright object means better data, more instruments trained on it, more opportunities to catch the faint whispers of its story before it disappears forever. Comets, like people, reveal their personality when they get closer to the heat. Put them near the sun, and they either stay cool and reserved or they explode into dramatic displays, spraying dust and gas like a shaken soda bottle. 3IATLAS seems to fall somewhere in the middle. Not the fireworks show that Borisov gave us, but not as stoic and silent as Oumuamua either. Instead, it's quietly expressive. Astronomers reported a faint coma, that hazy envelope of gas and dust, a glowing scarf wrapped around its icy nucleus. A sign that yes, the sun is starting to warm it up, and yes, it's alive enough to shed a little material. But the real surprise, a tail. At first, it was modest, just 3 arcseconds long, barely stretching across the starfield. But tails, like rumors, have a way of growing quickly. Amateur astronomers soon measured it, extending to more than 25,000 kilometers. Imagine a streamer so long it could wrap around Earth twice, fluttering behind this alien wanderer as it races past. And here's the best part. It wasn't just the big observatories making these discoveries. Forums like the Astronomers Telegram lit up with updates from both professionals and backyard astronomers. Someone in Spain posts a faint image. A group in Chile chimes in with tail measurements. A hobbyist in Arizona captures a glow no one expected. Piece by piece, a mosaic of the comet's personality comes together, collaboration across continents, united by curiosity. The tail itself is subtle, often lost in the haze of the coma in photographs. But even that is a clue. Tails depend on what the comet is made of. Different ices sublimate at different distances. From the Sunday, the shortness of 3I, Atlas's tail suggests a less dramatic mix, more reluctant to burn bright. A quiet traveler, whispering instead of shouting. But make no mistake, even quiet whispers carry meaning. In every grain of dust, every molecule of gas, is a story of a place we'll never visit, a star system light years away, a childhood environment frozen into ice and carried across the galaxy, and now, for a fleeting moment, shared with us. If you've ever noticed how sunsets paint the sky red while midday skies stay blue, you already understand something astronomers obsess over. Color is a story. Light carries secrets, and when it reflects off a comet, it tells us about what that comet is made of. So what about 3IATLAS? Well, it's red. Not Mars red, not stop sign red, but a subtler tint redder than the sun itself, and even redder than many of the rocky asteroids in our own system. Think of the muted, rusty glow of old brick dust, or the copper sheen of a well-worn penny. That's the kind of shade we're talking about. Why red? Most likely because its surface is coated in complex organic molecules and ices that have been baked, bombarded, and weathered by cosmic radiation for billions of years. Out in interstellar space, there's no atmosphere to shield you, just pure, raw radiation chiseling away at your surface until you glow with that reddish signature. It's like a suntan, except it takes a few billion years and no SPF can save you. Here's the trick though. Some of that reflected light doesn't come directly from the solid nucleus. It's scattered by the coma, that halo of dust and gas around the comet. We've seen this before with Borisov, where the coma's reflection drowned out the nucleus, making it harder to tell what the actual surface looked like underneath. 3IATLAS might be pulling the same trick looking redder than it really is because we're seeing its atmosphere, not its skin. Still, the redness matters. Astronomers compare it to a class of objects known as D-type asteroids, which orbit way out near Jupiter and beyond. Those rocks share the same deep, reddish hues, suggesting they too are covered in radiation-processed organics. It's a reminder that even in the frozen dark, chemistry is alive, quietly painting these bodies with color over eons. So, when you look at 3IATLAS through a telescope image, what you're seeing isn't just light. You're seeing age, exposure, the scars of a long journey across interstellar nothingness. And if that isn't poetic, an object wearing its history, in its colors, I don't know what is. Here's the thing about visitors like 3IATLAS. They don't just spark excitement, they also force astronomers to pull out their calculators and ask a very uncomfortable question: how many of these things are actually out there? Because if we've now seen 3 of them in less than a decade, you might assume the galaxy is absolutely teeming with interstellar debris. Highways of alien comets zooming past our front porch every other month. But the numbers tell a different, sobering story. Based on the discovery of 3IATLAS, scientists recalculated the density of interstellar objects in our neighborhood. The estimate came out to around 0.001 objects per cubic astronomical unit. Translation: space is still very, very empty. You could draw a cube with sides the length of the Earth, Sunday distance, and on average, only 1/1000th of an interstellar object would be inside it. In other words, if you're waiting for another alien comet to wander past, don't hold your breath. But here's the kicker. Those numbers depend entirely on what we can see. Atlas has been scanning for years and only caught this one. But what if there are hundreds of smaller wanderers, too faint to trigger alarms? Tiny shards, half a kilometer across, slipping by unnoticed because our instruments aren't sensitive enough. The density might be far greater than we think. We're just blind to most of it. This is a classic scientific conundrum. Absence of evidence is not evidence of absence. Just because our telescopes don't catch them doesn't mean they aren't there. It might just mean our technology, for all its sophistication, is like trying to count raindrops with a fishing net. You'll catch the big ones, sure, but the small ones, they slip through, invisible. And that's why every interstellar discovery matters so much. Each object isn't just a curiosity, it's a data point. One more dot on a graph that may one day show us how crowded the galaxy really is with these wandering time capsules. For now, though, the reality is both humbling and thrilling. Space is vast, mostly empty, and yet every so often, something ancient and alien drifts into view. When a new traveler arrives, the first thing we do is compare it to the ones we've already met. After all, 3 interstellar objects in total isn't much of a sample size. It's barely a starter pack, but it's enough for some early lessons. Think back to Oumuamua, our mysterious first guest in 2017. It came in silent, no coma, no tail, no visible gas jets, just a strange, elongated rock tumbling through space. Its brightness flickered wildly as it spun, making some scientists suggest it was cigar-shaped, others insisting it was flat like a cosmic pancake. Then came the wild theories. Maybe it was a shard from a shattered planet. Maybe a primordial relic. Maybe even if you squint hard enough an alien probe. The lack of activity was its defining feature. It was the strong, silent type. Then in 2019, Borisov showed up. If Oumuamua was a stone-faced poker player, Borisov was the opposite. Loud, messy, impossible to ignore. It flared with gas. Its coma expanded daily. Its tail stretched more than 140,000 kilometers into space. This was a comet in full performance mode, a true ice and dust traveler from another star system. It left no doubt about its nature. And now, 3IATLAS. Somewhere between the two, not inert like Oumuamua, not flamboyant like Borisov. A moderate coma, a modest tail. Enough activity to prove its icy nature, but not enough to turn it into a galactic firework. In personality terms, if Oumuamua was the quiet artist and Borisov the extroverted party guest, then 3IATLAS is the polite traveler who brings a bottle of wine, chats for a bit, and then leaves without making a scene. But here's the catch. These differences aren't just quirks. They tell us something deeper about where these objects came from, how they formed, and what kind of star systems gave them birth. Each one is a puzzle piece from a different cosmic neighborhood, and together they're hinting at the diversity of environments across the galaxy. So when we line them up, silent rock, flamboyant comet, steady drifter, we're not just making personality charts. We're building a comparative catalog, a way to map the unseen corners of the universe through the crumbs it sends our way. So what do these differences actually mean? Because in science, quirks aren't just quirks. They're fingerprints, traces of the environment each comet once called home. Take Oumuamua. Its lack of activity baffled astronomers. Comets are supposed to light up when they near the sun, yet Oumuamua stayed stubbornly quiet. Some argued it was rocky, a dense shard ripped from a planet that once orbited another star. Others suggested it might have been made of exotic ices, like hydrogen or nitrogen, that evaporated too quickly to leave a visible tail. Still, others leaned into the mystery. Maybe it wasn't natural at all. To this day, we don't have a neat answer. It remains the enigma, the locked box of the trio. Borisov, on the other hand, spilled secrets everywhere. Its coma chemistry revealed an unusually high abundance of carbon monoxide compared to water, far higher than in typical comets here in our solar system. That suggests Borisov formed in a colder, carbon-rich nursery, possibly around a red dwarf star system. In other words, Borisov carried the signature of its birthplace, like a passport stamp from a frozen world we'll never visit. So where does 3IATLAS fit? Its modest activity and reddish glow offer tantalizing hints. The coma tells us it has ices, yes, but not in the abundance of Borisov. The light suggests organics on its surface, weathered by billions of years of interstellar exposure. Its orbit and speed hint at an ejection long ago, perhaps during the chaotic early days of some distant planetary system. It's as if each of these visitors represents a different flavor of planetary system. Oumuamua, rocky, barren, born in a violent place. Borisov, icy, volatile, raised in the chill of a carbon-rich nursery. 3IATLAS, something in between a steady traveler carrying both dust and ice, weathered into a reddish hue by the endless void. What's extraordinary is that we can even make these inferences at all. We're talking about objects that are here for only months, racing past at unimaginable speeds, never to return. And yet, in those brief glimpses, we can reconstruct parts of their life stories. We can say, "You were born near a cold red star," or "You were forged in fire and left rocky." It's forensic astronomy, piecing together galactic histories from the crumbs that wander into our sky. And with 3IATLAS, we're adding another page to that interstellar scrapbook. Here's where things get downright mind-bending. Because it's not just about what 3IATLAS is made of, it's about how old it might be. And the answer? Older than anything you've ever touched, seen, or imagined in your daily life. Astronomers use velocity as a kind of cosmic clock. Objects tend to pick up speed the longer they've been free-floating in the galaxy. And when they crunched the numbers for 3IATLAS, they realized it could be between 3 and 11 billion years old. Yes, billion, with a B. To put that in perspective, Earth itself is about 4.5 billion years old. Our planet wasn't even finished cooling when this comet may have already been on the move. If the higher end of the estimate is right, 3IATLAS might be nearly as old as the galaxy itself. It has been drifting longer than our sun has been shining, longer than our solar system has even existed. Think about that. Every civilization, every story, every fleeting human drama, it's all younger than this one chunk of ice and dust. If you stacked up human history, from the first cave paintings to TikTok, it wouldn't even make a scratch on its timeline. This thing is ancient in a way that makes pyramids look like fresh construction projects. And yet, here it is, passing close enough for us to notice, to measure, to wonder. A relic from a time when the galaxy was young, when stars were just beginning to settle into their orbits, when the raw ingredients of planets were still swirling in primordial chaos. 3IATLAS has seen it all. Silent, unchanging, drifting endlessly. The poetry writes itself, a traveler older than our world, brushing past our sun as if to remind us that we are new, fragile, temporary. It's humbling, it's terrifying, and it's beautiful. Or, if you'd prefer a simpler perspective, this rock is so old it makes your grandma's grandma look like a toddler. If you've ever seen a kid handed a brand new gadget, you know the look. Wide eyes, twitching fingers, a mixture of awe and impatience. That's exactly how astronomers act when the universe drops something like 3IATLAS into their lap. A shiny new toy. With only one catch, it comes with an expiration date. Every telescope that can pivot toward the sky is being begged, bribed, or scheduled to watch it. The professionals want their high-resolution spectra, breaking the comet's light into rainbow fingerprints that reveal its chemical recipe. The amateurs want their grainy photos to post online with captions like, "I swear it's real. Just squint." And everyone wants a piece of the data before the guest slips out the door. This isn't the first time we've seen such urgency. When Oumuamua zipped by, scientists scrambled so fast they barely had time to agree on how to pronounce its name. With Borisov, telescopes from Hubble to backyard reflectors lined up to capture its fiery performance. And now, 3IATLAS is getting the same treatment, though with an even stronger sense of we may never get another chance like this. And the beauty of our era? This isn't confined to ivory towers or billion-dollar observatories. Citizen astronomy is alive and well. A retiree in Spain, a grad student in Chile, a hobbyist in Arizona, they're all pointing their scopes, sharing results on forums, piecing together a global mosaic of this alien traveler. In another century, only a handful of professionals would have even known this comet existed. Today, thousands of eyes are on it. The universe has never felt so collaborative. And yet, beneath the excitement, there's a quiet urgency. These moments don't last. The data must be gathered now, before the comet fades back into the dark. Every spectrum, every brightness curve, every blurry amateur image, each one is a thread in a story billions of years in the making. It's a reminder that science, for all its equations and graphs, is also about play, about curiosity, about that childlike thrill of getting a new toy and knowing, deep down, that what you're holding is a gift from the universe itself. So where does that leave us, practically speaking? What do we, the insomniacs and the stargazers, actually get to see in the months ahead? Well, if you've got a telescope or a very generous friend who owns one, mark your calendar. Starting in September, 3IATLAS will creep into view for Earth-based observers. Not with the naked eye, mind you. Don't step outside expecting a blazing streak across the sky. This isn't Halley's Comet putting on a public show. But through even a modest amateur telescope, you might catch that faint glow, that dusty halo, that subtle tail stretching across the starfield. Then comes the big date, the 30th of October, perihelion. That's when the comet will swing closest to the Sun, just inside the orbit of Mars. Picture it brushing past the Sun's warmth, the ices in its core sighing into vapor, the halo blooming a little brighter. For astronomers, that's the golden hour, the window, when the comet is most active, most generous with its secrets. But don't worry if you miss it. After perihelion, it will duck behind the Sun for a few weeks, then re-emerge in early December for another round of viewing. A cosmic encore before slipping out forever. And here's the wonderful part. You don't even need a telescope to feel involved. NASA's JPL Horizons tool lets you track the comet's position in real time. You can literally watch its coordinates update day by day, tracing its hyperbolic escape route. It's like following a friend's road trip on Google Maps, except the friend is a 10-kilometer chunk of ice older than Earth, and the road is the galaxy. So what comes next? Observations, measurements, maybe a surprise or two, if the comet decides to flare up dramatically. But for us ordinary mortals, what comes next is the joy of paying attention, of knowing that somewhere above your head, racing past the Sun at 58 kilometers per second, is an alien traveler you will never see again. So here we are, a faint, red-tinged traveler from another star system, drifting through our skies for just a brief season before it vanishes forever. 3 interstellar visitors in recorded history, Oumuamua, Borisov, and now 3IATLAS, each with their own quirks, each teaching us something new, each reminding us that our solar system is not an island, but a crossroads. And that's what makes 3IATLAS so captivating. It's not just the data, the eccentric orbit, the lazy 29-hour rotation, the faint coma, the modest tail. It's the symbolism. This comet has been wandering longer than Earth has been alive. It has seen galaxies collide, stars ignite and die, entire civilizations rise and fall on worlds we will never know. And now, in the year 2025, it just happens to swing past our little campfire in the dark. Will it change your daily life? The grocery store will still run out of milk. Your emails will still pile up. The cat will still ignore you. But knowing that a 10-kilometer block of alien ice, billions of years old, is quietly gliding past our sun, that knowledge humbles you. It widens your sense of scale. It nudges your perspective, reminding you that our dramas, our anxieties, our fleeting victories are tiny flickers against a canvas so immense it laughs at our calendars. And yet, that's the gift. Because being reminded of our smallness doesn't diminish us, it makes our moments feel sharper, richer. Here we are, fragile apes on a small blue rock, with brains clever enough to notice when the universe sends us a guest. We can chart its orbit, measure its color, argue about its chemistry, and marvel at its story. For a species barely a few 100,000 years old, that's not bad. So, when you step outside tonight, take a second, look up. Somewhere out there, beyond the glare of the city lights, is a comet that has traveled across billions of years and trillions of kilometers just to pass by, indifferent to us, but generous enough to be seen. And for one fleeting moment, you get to share the sky with it. Stay curious, stay small, and never stop looking up, because who knows when the next wanderer will arrive or what secrets it will carry with it.